So, welcome back to XR Advance. We have today with us Alex Klippel from Penn State, Director of the Center for Immersive Experiences. Very excited to have him here. He's a little different than our other speakers, coming from geography, and here to talk about platial cognition. Alex, take it away.
Stephen, thank you so much for having me and for inviting me to give a presentation. It's great. We had a chance to attend some of the previous ones. It's such a fantastic opportunity to bring the community together and move forward. Yes, quick note on the self-advertisement. Yes, Penn State will have a Center for Immersive Experiences. We are in the launch process, so we're excited to join the family of centers in the US. First, I would like to explain the term platial. So it is essentially a combination of place and spatial. If you are in geography or in any other discipline that values taking students to a particular location on the earth, then for example, education, then place is the most central term. So I thought I combine the two of them, which some of my peers have done before me, and talk about how we integrate place experiences into the classroom, but then also structure basic research around those experiences to advance platial cognition, essentially. What I found interesting and fascinating is that the research themes that we identified as part of the workshop really very nicely play together with platial ideas and with platial cognition. As we talk about dynamic content generation, we talk about how to address issues of cyber sickness if we now turn immersive learning experiences into large-scale curricular activities. And we, of course, talk about spatial cognition. To give you a couple of examples of what we are doing is we are basically creating immersive experiences for a number of different environments. So here, just a couple of examples of a wetland area just outside the town of State College, taken with drone images on the upper left corner, and then an energy site, a fracking site in Pennsylvania on the upper right corner, a site in the Lassen Forest, the Ishi Wilderness in the lower right corner, where we created an immersive experiences for fire ecology and for understanding fire ecology. And then on the lower right, we have an image from Tunantunich in Belize, site of the Mayan ruins. So those kinds of places are ideally an integral part of education and of learning, but often they are not. And so immersive experiences allow us to bring these places into the classroom. As you see already, some of the images are taken with drone images, and that is part of our research then, that we try to identify what do we actually gain, for example, by having images taken at an elevated perspective compared to just as the ground perspective. And I will come back to that in a little while. I have a couple of more advanced examples as well that we have developed for places that are usually inaccessible. One of our favorite examples is the Trinukagígar volcano on Iceland, where one of my colleagues flew a drone into the volcano, collected LiDAR data, and collected photogrammetry data, and we pulled this data together into an experience. I should admit that this is actually a dormant volcano. So it is a volcano that you can actually access all through via an elevator. Nonetheless, it's kind of a site that only very few people have the chance to actually visit. We put this, as I said, into Unity. So we created what we call an immersive workbench around this. So here's just a little video that shows what this then looks like. So again, thinking through how these kinds of sites with the data, such as LiDAR data about these structures becoming also available in abundance, can be made accessible for this kind of place-based learning is something that is at the verge of really becoming available at the moment at scale. What you've seen here is sort of the workbench, as I said, that we created, switching back and forth between a LiDAR point cloud, and this is the reconstruction using structure from motion photogrammetry. In the order of time, I might just move on, but these videos are also available on YouTube. I have a second project that I just really briefly wanted to mention, because what the combination of the 3D modeling and immersive technologies allow us to do as well is to have places that are really not accessible at the moment, such as the forest of the future. We have a project funded through NSF that addresses exactly this question, working together with the Menominee in Wisconsin, who are very much into, or who are foresters, and thinking about how can we actually understand what a forest, for example, in 2050 might look like under different climate change scenarios. Again, little excursion here. So we use what is called LENDIS-2, which is an ecology model that actually predicts what the forest composition looks like. I'm not going into any detail here, but what standardized or standard from a standard perspective, the output is that we have data such as species and then biomass per tree species. This is, of course, something that can be visualized in form of maps, but it cannot be visualized in form of a 3D model such that it would actually become an experiential forest. What we would need for that is such things such as species, but also height, crown width, and the number of trees. We were able to derive this information from a database called FIA, the Forest Inventory Analysis Program from the US Forest Service. So we regressed over experimental plots that they have and derived the kind of data that we need for the visualization. What we can then do is, on basically scientific grounds, create forests that are the forest of the future. There's actually a link to a video with a similar workbench that I showed before. I'm not showing the video again, just in order to save some time. So the bottom line is that we really have a lot of opportunities to make places of any kind accessible in immersive experiences. And the need then is to think about what does it actually mean in order to be able to access these places? How can we make them accessible in ways not possible in physical reality, for example, that really enhances the user experience, but also learning and then also environmental decision making. To advance this, we have specialized on empirical evaluations and empirical evaluations on primarily immersive virtual field trips. Instead of using the virtual field trips, sorry, just as a reminder, so the virtual field trips, again, ideally, if we learn something about a place on Earth, we would be able to be present in that place to contextualize and scaffold the learning process. What we did is we started thinking about what is actually a potential research framework for advancing the science and the understanding of immersive field trip experiences. As looking through the literature, a framework for that specifically did not exist. The framework that we came up with has essentially two parts to it. One is what we call an virtual field trip taxonomy. And this taxonomy is a simple one in 3 parts. where we separate and differentiate a basic, a plus, and an advanced virtual field trip. Basic virtual field trips are essentially replications of the physical reality. The plus version is a replication of the physical reality, but allows access to angles from of the physical reality from different perspectives. So, such as taking 360 images with a drone or a particularly large tripod. Here's an example from the field trip that I will be discussing in a second, where on the left side you have a ground perspective, and on the right side you have the same image or the same location, but taken at 27 feet height with a very long tripod. In this case, it's a geosciences field trip, and you can easily imagine that the more horizontal perspective on the different rock layers allows for a very, very different way of seeing and understanding the potentially underlying processes. The advanced version is then something that requires simulations of the kind that I've shown before. So I just show this again. So if you have a place such as a forest in the future, such as geological processes in the past, this is something that requires not just replicating physical reality, but to simulate what the reality potentially, or a place could potentially look like. So this is the first part. The second part is what we call sensatium, and it is a little bit of a mouthful. It's called the sensing scalability trade-off continuum. And essentially, we use it as a way to structure our own deployment of immersive learning experiences. What we ultimately are interested in is whether we need very high-end systems to deliver effective and efficient learning content, or whether we are able to deliver adequate learning experiences with lower-end systems. What we did is we organized these two aspects into a diagram. On the bottom axis, you see the virtual field trip taxonomy, so the basic, plus, and advanced version, and then on the vertical axis, you have the sensatium differentiations. And there's a lot to discuss this, but it helped us really to create a framework for something that we have been working on for essentially 2 to 3 years now. In addition to the two axes, we started to create spin-offs, so empirical spin-offs addressing specific aspects of immersive virtual field trips, such as this aspect of scale and what changes for people if we give them access to a place at different scales, but also things such as locomotion. So what effects does different modes of locomotion have on, for example, understanding an environment. The numbers that you've seen are the different semesters in which we collected data. We collected data in 3 semesters, and then ultimately, as I mentioned before, we're trying to find sort of this sweet spot that potentially could lie on this curve. So where we can make a recommendation for which kind of environment and which kind of content to actually use to achieve a certain learning output. This could lie on this axis, or it could lie in one of the extremes. So it might be that we are happy with a low entry-level virtual reality product and a basic virtual field trip, but it could also be that we find that we really need advanced immersive virtual field trips delivered through high-end systems. The Reedsville Bald Eagle formation is something that's just outside our small town of State College here. And the reason why we used this rather unspectacular site is that it actually allows us to run controlled studies. Studies that are generally look like a subgroup of students goes on an actual field trip, and another group of students goes on the virtual field trip that corresponds to the actual field trip. We use a combination of 360 imagery as well as 3D models. So here's just an example of a 3D model we created of parts of the outcrop. These models then allow students to perform essentially the same task that students in the field would perform. In this case, measuring the width of the rock layers to create stratigraphic maps. Students receive the results at the end of their experience to then be able to do their homework assignments. And just a couple of examples on the results. So we do both qualitative and quantitative assessments. So the question I learned a lot from the virtual field trip was answered significantly more positive from students using the HTC Vive going on the virtual field trip than students going on the actual field trip. We also used a composite score for the overall field trip enjoyment. And we found a similar picture where we had students answering significantly more positive across 4 different questions on the overall field trip enjoyment. And then one thing that we really did not expect was the grades that the students received. So we actually found that the students in the virtual field trip had significantly better lab grades than the students in the actual field trip. I'm not saying that this is something that is only due to the putting an immersive headset on. There are lots and lots of reasons, because it is a complex endeavor to run a field trip and a virtual field trip. So everything from there are no mobile phones in a virtual field trip unless you put them in. There are fewer distractions, there are no cars passing by, and so on and so forth. So there's a lot of things that are outside of our control. But the positive aspect is that the students engage with the material and also perform definitely not worse than people who are going on an actual field trip. We were able to replicate these findings. We did run the virtual field trip again. The first one was actually a basic virtual field trip, so we only took ground images. In the spring of 2018, we moved this field trip into the realm of the Plus virtual field trip, meaning that we took, in addition to ground images, 360 images at a height of 27 feet. So students were able to not just explore the site, but also to explore the site from an elevated perspective. There's an additional change that we had to do as the instructor of the course was extremely supportive, but he really wanted all the students to experience the actual field trip and not have some students experience the virtual field trip exclusively. So we had students going into the actual field trip into the virtual field trip before they went into the actual field trip. So what we found here then is that we were able to also assess the level of preparation that people felt before going to the actual field trip. And if you compare, so AFT is the actual field trip, the preparation that is sort of the standard in form of lecture slides, lab sessions, plus the one supported through the virtual field trip, students feel significantly better prepared for the actual field trip if they go through a virtual field trip before. We were also able to replicate all the findings that we had before, such as the self-assessed learning experience, as well as the overall enjoyment. The one exception that we had was the lab grades. Lab grades were collected after both experiences. So in this case, we did not find a significant difference between the two groups, just a slightly better performance of the virtual field trip participants. Lab grades, generally speaking, and this is one thing that we're working on, are a particularly crude instrument to assess specific learning outcomes. So we are currently working on a more detailed rubric that allows us to make assessments at a finer level of granularity. One thing that I would like to come back to is this question of, does it help students to have an elevated perspective? So essentially moving from a basic to a plus virtual field trip. As a reminder, in the basic version, we had only ground perspectives, ground images. And then in the plus version, we also have an elevated perspective, which we made accessible in the virtual experience through a little red disc at the top of the image, which the students could simply click on, and then they would be beamed up to the 27 feet elevated perspective to give them a perspective on the outcrop. With that, we were able to assess then the effects. In this first case, we assessed it qualitatively through the spatial situation model, which is part of a presence questionnaire by Forderer. And what we find is that we definitely see a trend. So if we compare the actual field trip, actually do I have just a second? Oh. Yeah. Here, there we go. We have the actual field trip here and compared it to the basic virtual field trip and then the plus version. So we see this trend that then also turns out to be statistically significant if you compare the plus version to the actual field trip. So this was the first step in sort of assessing what the value of experiences that we can offer that go beyond the experiences of physical reality actually can mean in terms of student experiences and student learning. We had another version of this field trip in the fall of 2018. We call this the virtual immersive learning in the wild. In the wild because instead of having students come to our lab and administering the different experiences through an experimenter in our lab in a very controlled environment, we have essentially used 4 locations that are available throughout the university or the main campus of the university at University Park. This is the Dreamery, which is an emerging technology facility, IMEX, which is the Immersive Experience Laboratory, and then we have 2 VR rooms in 2 different libraries. So the students actually had to sign up online for these learning experiences. 3 of these locations had HTC Vives, and the IMEX has facilities in form of swivel chairs. And we redesigned the virtual field trip now for a Oculus Go experience, which has, I would say, a number of drawbacks. So there's fewer degrees of freedom. So the user tracking is by no means as sophisticated as the Vive. And there's limited forms of interactivity. Students have to sit down for safety purposes. But the distinct advantage is that there can also be a lot more students participating in the immersive experiences at the same time. This was actually necessary, so this is a side anecdote, because the actual field site in the fall of last year was actually a blast zone. So there's a big road project underway, and the geoscientists lost the site with no proper replacement that they could find. So we had a total of 70 students going through this experience, of which 44 agreed to be part of the empirical evaluation. The data overall is very messy, and I'm very happy to talk much more about this if you're interested. But I just wanted to briefly show one slide that really surprised us. So these are the self-assessed learning experiences. So here you have the two that you have seen before. So very high values, both in the fall and in the spring of 2018. And then in the fall of 2018, if we separate the Go and the Vive, we actually see that the Vive has the lowest number, the lowest agreement score on this scale, and actually has significantly the lowest value. So this was something we definitely did not expect, especially in the comparison to the Go. And what this actually shows is a couple of things that are important as we are going mainstream with immersive experiences. So in this case, the experience was mandatory for all students in the class. And so we find that there are a number of students who really do not like immersive experience, especially when they're in a geosciences class. And we also find that there are still some practical issues with sending students into a VR room all by themselves, basically going through this experience. In contrast, the Go had an experimenter there because it was the first time that we had a version for the Go, so we made sure that nothing goes wrong. They had it as a group experience, and so had a very different experience than being all by themselves in a VR room in a library. So bottom line is that if we want to go mainstream with immersive learning experiences, there's still a fair number of things that we need to address. A couple of things on current developments and then also the spin-offs that I mentioned before. So we have singled out a number of different topics that are attached to Platial cognition, to this place-based learning experiences. One is locomotion in VR. So we actually ran a study on the effects of different forms of locomotion on spatial learning. So here's an example of the different forms of locomotion that we realized. So we compared a desktop teleportation with a desktop continuous translation. So the continuous translation is what we are mostly used from sort of standard gaming environments. The teleportation we implemented because we wanted to be able to compare the desktop teleportation to the teleportation in the Vive. When we ran this study, it was just before Google came out with their solution for continuous locomotion in the fully immersive headsets, which essentially only works if you adjust the field of view and blur the ground, or reduce it to a really slow speed in order to prevent cyber sickness. What we found with these results was something, again, that we did not quite expect. We thought that providing students with this additional aspect of being able to look around, so essentially adding proprioceptive information to the experiences, comparing a desktop to a fully immersive experience, would definitely enhance the learning outcome. but this was not the case. In this case, it's even, so the higher the bar is negative, this is the pointing error that we assessed in a paradigm called Silkton that has routes that allow for comparing within and between landmark judgment tasks. And we find that the Vive teleportation, although not statistically significantly different from the desktop teleportation and the desktop continuous movement, is actually the worst performing one of the three. So there are factors in there, again, that may have something to do with novelty of the medium. It may also have to do with the information that we lose if we teleport in contrast to continuous motion, which offers the visual flow information that we are naturally used to. So again, to finding the right form of locomotion in virtual environments that often require us to be inventive about the way that we get from one location to the next is something that certainly does require some more information, some more research. Scale, so I briefly mentioned this aspect before. So if we give users in an immersive experience access to an environment at different scales, what does it actually mean in terms of them being able to understand an environment? We have seen a first qualitative assessment that we attached to the virtual field trip. In order to make this assessment now more formal, we actually designed an environment specifically for this assessment. It's an environment that is mimicked after a study by Tobias Meilinger from the Max Planck Institute in Germany, in Tübingen, where we have a ground perspective at 4.5 feet. And we also provide participants with a 16.5 feet elevated perspective. The difference, as you can see in these two images, then is that the number of landmarks that are available at any particular point is different. And we use the maze to be able to control it. And at first, we only have basically one additional landmark that we add to participants' experience. We ran a study on this learning environment as well. And we find a couple of things that are perfectly consistent with what we would predict. So separating the participants into high and low spatial ability participants, we find that for the ground perspective, the participants with high spatial abilities outperform significantly the students with low spatial abilities. However, and then also we find that over time, so we had several sessions, that over time, comparing session 1 to session 2, the participants improved in their learning performance. What kind of amazed us was that if we combine a ground perspective with the elevated perspective, so the G and E, that we are not finding a significant improvement, and especially in case of the high performers, we actually find that they seem to have struggled more with this setup. Again, it is something that intuitively makes sense, but for the purposes of controlling all the factors, if you don't want to increase the learning time, we actually had to reduce the time that the participants were allowed to spend in each of the different views. So what this meant was that they spent less time and had this additional aspect of navigating up and down. We're actually currently analyzing this data, so we used additionally a NASA text questionnaire on cognitive load. And I'm also currently running follow-up studies that hopefully will help us to identify the exact factors that contribute to the not expected results that the students who were given the elevated perspective in addition to the ground perspective did not outperform in terms of creating correct mental representation. So in conclusion, so place and place-based education and research is a natural benefactor of anything related to XR. So whether this is augmented, mixed, or virtual reality, applications concerning place are relevant for all the different areas that we, or for most of the 8 areas that we have identified as part of the first workshop. What we found is that there's not a particularly good framework that would help us identify what are the most sensible next steps in place-based learning supported through immersive experience. And then what we find is that the integration of immersive experiences into different learning environments is something that has a lot more data to really make sure that the design of the experiences are really supporting the learning outcomes that we would like to see. With that, I would like to thank you, many students who have contributed to this research, especially my graduate students and postdocs without whom this research would not have been possible, as well as different funding sources. Thank you.
This is okay? Okay. Hey, Alex, John Kelly here. I really enjoyed your talk. And I have a couple of questions, but one was that this is more of an observation or a clarification at least. It seemed like the virtual, so like when they would visit the site of this rock outcropping, in the virtual condition, it was basically a static rendering of what you would really see if you were to visit that site. Is that true?
Yeah, I shortened it quite a bit. So what we do is we collect a lot of 360 images, and we collect high resolution 360 images, and then we have implemented a Google Street View like navigation that mimics the sequence that they would normally go through at the actual outcrop.
I see.
And then we enhance the experience by sort of audio scripts that the students will hear, as well as additional information that is available at the outcrop. So apologies, I took this out because I thought I did not have enough time.
No, that's helpful.
So they can actually see then, for example, high resolution images of grain size. And they can also bring up information that they normally have in their lab handbook, such as a chart about what different grain sizes mean in terms of the genesis of different rock formations. And then the image that I showed was one part of this experience where we created a 3D model of the outcrop. And that is necessary to allow students to perform what they normally perform at the sites. And in this particular case, it is measuring the width of the different rock layers that they then use in their homework assignment to create a stratigraphic map.
I see. So it's kind of a blend between panoramas and then this 3D model that they interact with.
Yes, so we essentially use, so if we don't have to use the 3D model, we often go with the 360 images because they are a lot less demanding on the environment. So again, especially thinking about a scalability issue, 3D models are a little tricky for systems such as an Oculus Go. If we can get away with the 360 images, then that's tremendously easier to realize than having a 3D model. But then if they need a 3D model to do measurements, we create a 3D model so that they can perform what they need to perform in order to sort of have the same experience that the students at the actual field site would have.
Right, right. And I have to say, when I saw one of your earlier slides about, they enjoyed the virtual experience maybe more than the real one, and I think they felt sort of like if I'm remembering correctly, that they felt like they learned more, and I thought, oh, well, that's setting them up for some kind of failure later on because perhaps they didn't learn more actually, but in fact they did, so I was really impressed by that.
Yeah, so I mean, we are super happy with the outcome. So our minimum standard is that the virtual field trip should not lead to a decrease in grades. So we never quite expected that they would actually be better because there's such a strong advocacy for field trips in many of these sciences, and rightfully so. So there's a lot of hesitation and skepticism that we are meeting and have to address by convincing our colleagues in, for example, geosciences, that there is a place for immersive experiences, even in a field such as geosciences.
Yeah, and my last comment is that it's impressive not only that they learned as much or more in the virtual environment, particularly since it seems like there's so much room for additional learning through, like simulations of changes over time and ways of, things that are hard for students to grasp when looking at something static and inferring the process. You could actually show them the process. And they would presumably learn
that's
more.
exactly the point. I mean, the first experiences that we created were really just very basic field trips, also with the idea in mind that if this is something that works, then basically every person who's going on field trips has the ability to collect and curate a virtual field trip essentially. So that's why we thought about, okay, let's start with the basic version and then move ahead from there, so that you can really sort of try to quantify what is it actually that I gain from sort of moving all the way into an advanced version where I actually include simulations.
Right.
Or can I just essentially just stick with the basic version and at least I don't mess up my students and their grades. Yes.
Thank you, Alex. I have other questions, but I'm going to wait and see if there are other people who would like to ask questions.
So I had a clarification question about your replication study. Your first one, when students actually went to the actual field trip and then did this virtual field trip.
Yes.
And I think you mentioned this, those were the same students who went on the actual field trip and then did the virtual field trip, and then did they do it in that order?
No, it was the other way around. So the students, so in the second one, so the spring of 2018, students went onto the virtual field trip first, and then they went to the actual field trip.
Okay.
So that was upon request of the instructor, who said that, okay, I'm happy to provide clicker points and to help you recruit students, but I want everyone to actually go into the field.
Okay. Because I was under the impression that it was the other way around, and that their heightened, their perceived learning experience was heightened because maybe they got sort of a second exposure to, the environment that they were learning.
No, so the order was virtual and then actual, and the only thing that we additionally requested was that we asked them whether they felt better prepared, which also is this is what we expected, right? So in addition to the lectures, they went through a virtual field trip. So if they would not feel better prepared, that would be a matter of concern. And then what we did see is, the statistically significant, or the significance level, they increased. So the students in the virtual field trip were even happier than they were before, which is maybe due to the fact that they also had an elevated perspective. But again, this is why we are singling out now specific experiments like the one with scale, like the one with locomotion, because the field trip itself is pretty complex. So it's a 35-minute experience. So it's sometimes a little tricky to then pin down exactly why sort of a learning gain, for example, occurred. So because it's not just one experiment, it's a full experience.
Okay. Thank you.
So on the field experiences, I'm thinking about the fact that if you and I went out to a mountain, you would have a much better sense than I would about how the rock fractures, and you might be looking for very different things. Maybe I'm just looking for gold or pretty rocks to take home.
Yeah.
So when you provide a virtual field experience, how do you cater to the task at hand and to the previous experience of the students? You know, like if I were going on a virtual forest experience field trip, I might be looking for Dutch elm disease, you know, and signs of certain pesticides, as opposed to you might be looking for leaf formation or something.
I mean, okay. So to some extent, this is what we did with the different media that we use to convey and to communicate the field trip. So we use the 360 images or enhanced 360 images when they are appropriate, and we use the 3D model when the 3D model is appropriate. To answer your question, so depending on what your task is, it might be that in your case, it would be useful to have definitely close-up images of, for example, Elm's yellow. What this looks like, it could be that there is, I mean, you can essentially integrate any kind of media that then provides the information that you need for this particular field trip. But that's something that that's actually for us one of the most challenging aspects in kind of scaling these experiences up. It's actually to find instructors and to work with instructors who are enthusiastic enough to basically put in the effort and help us create content for these learning experiences. And we are fortunate that we have a internal strategic plan proposal grant that allows us to do that with people from geosciences and also with people from biology. So in this summer, we will start with branching out to biology to increase the availability of immersive learning experiences. So yeah.
Yeah, I'm thinking of also differences, like if I go to the local science center, there will be aquariums with snakes in them and turtles and, you know, greenery and little ponds. But I can also go to the actual nature preserve and see snakes and turtles and ponds.
Yeah.
And so, you know, when do I do each one, and under what conditions is one better than the other? And it's these same sort of questions you have to answer with your faculty, I guess.
Yes, and I think that's actually a great example. So this was one of the things that I always thought is missing in the museums, that you see a map where this creature has been found or is normally found, and then you see this really, really small habitat that they allow in the museum, but you never can really understand in what kind of context this creature actually lives. And I think this is actually a perfect example, and I hope that I will be able to convince our local science center here to do something like that, to really provide a combination of, if you have a display, then at least give people access to an immersive experience of what the habitat actually looks like. Because I think this is so critical to really understand an animal. And it can just not be conveyed by just like giving people a dot on a map that is really not particularly telling unless you grew up in that area.
Mm-hmm. All right, let's thank Alex once again. Very nice.
Thank you for having me.